Hello chemistry students. Today in class we learned to balance nuclear reactions, and I wanted to make this video to give you a reference to help you with your homework if you needed it. So let's first go over the parts of a nuclear reaction. So every nuclear reaction is going to have an arrow in it, and on the left side of the arrow you have the elements that you're starting with or your reactants. On the right-hand side of the arrow, you have the result of the reaction or the products. Now, as you'll see in this handout, sometimes you'll have one reactant. Sometimes you'll have more than one reactant. Sometimes you'll have one product and sometimes you'll have more than one product. No matter how many of each thing you have on each side of the arrow, one thing always remains the same, and that is this. The mass number on the reactant side must equal the sum of the mass numbers that are on the product side. And the atomic number on the reactant side must equal the sum of the atomic numbers that are on the product side. Okay, so let me erase this, but I am going to keep my pink and green circles here. And let's write this in orange. Okay, so we have, well, maybe I should erase these. So we have radium-220 is going to undergo alpha decay, and I know it's alpha decay because this is an alpha particle, and it's going to form some other isotope, and that's what I need to figure out. I need to figure out what's the mass number of the isotope, what's the atomic number of the isotope, and what is the symbol for the isotope. Well, on my left side, my reactant side, I have a mass number of 220. And on my product side, I know I have one mass number of 4, but what I have to do is figure out what is the mass number of my mystery radioisotope. Well, remember that the sum of the mass numbers on the product side must equal the mass number that's on the reactant side. So 4 plus some number must give me 220. So what number plus 4 gives me 220? If you answered 216, then you would be right, because 216 plus 4 gives me 220. Okay, now let's look at our atomic number. Our atomic number on the reactant side is 88. On the product side, I have 2, and I have to figure out what my atomic number is for my radioisotope. Well, remember that the atomic numbers on the product side has to add up to equal 88. So 2 plus what number gives me 88? My answer is 86. Now what I need to do is figure out what my abbreviation is for the element that was created. And to figure that out, I use the number 86. I have to use my atomic number, because remember, every element on the periodic table has a unique atomic number. So I just have to find atomic number 86 on my periodic table, and I have found it. It is right there, Rn, radon. And now my problem is done. So my isotope is radon-216. So radium-220 undergoes alpha decay and produces radon 216. Okay, now let's try another problem. Let's take a look here at number 2. Number 2 says that polonium 218 is going to undergo some kind of decay. I don't know what kind. That's what I have to figure out. Because 214 over 82 PB, like that's not an alpha particle, that's not a beta particle, it's not gamma, it's just another radioisotope. So whereas in number 1, I was told the kind of decay that it was going to undergo and I needed to figure out the radioisotope that was produced, here it's a little bit opposite. I am given the radioisotope that was produced, but now I have to figure out what kind of decay it underwent. But guess what? It's not harder. The reason why is because the principle is the same. So my mass number on the reactant side has to equal the sum of the mass numbers that are on the product side. So 214 plus what number gives me 218? And if it helps you, 214 plus x equals 218. 214 plus some number gives me 218. To figure out x, all I have to do is subtract 214 from each side, and I get x. Whoops, I gave you the answer. X is equal to 4. So that means that my number up here at the top, my mass number for my particle, is 4. Now, I have to figure out what my bottom number is, and you guys might already know what it is. But here we go. This is how you would figure it out. My atomic number on the reactant side is 84. And on the product side, I have an atomic number of 82 for lead, but I need to know what my atomic number is here. So I'm going to do the same thing that I did over on the side here. So some number, which I don't know, plus 82 equals 84. To figure this out, I have to subtract 82 from both sides, and x is equal to 2. And that is my atomic number. Now, atomic number 2 is right here. That's helium. So 4 over 2 He is my final answer, which basically means that polonium 218 is going to undergo alpha decay because this is the symbol for an alpha particle, and it's also going to produce the radioisotope lead 214. All right, so those were 2 alpha particle problems, and those were 2 where you had to figure out what the products were. But let's take a look at number 4, because number 4 is a little bit different in that we need to figure out what my reactant is. But remember, it's just the same thing. The mass numbers on the product side have to equal the mass number on the reactant side. So all I have to do is add 207 plus 4, and what I get is 211. On the bottom, 81 plus 2 is equal to 83. So that is my atomic number. And now I'm going to use my atomic number, 83, to figure out what my element is. And there it is. Atomic number 83 is bismuth. So the thing to remember is that your atomic numbers on the right of the arrow have to equal the atomic number on the left. And the mass numbers also have to equal across the arrow. Okay, so let's try one more. Here, let's try number 7. So here with number 7, here's my arrow. And I have 2 reactants here on the reactant side, and I'm going to have 2 products on the product side. But again, I know that regardless of how many I have, the mass numbers that are on the reactant side have to equal the mass numbers that are on the product side. So here's how I would do it. Oops. Oh my goodness. There we go. Okay, so 14 plus 4 gives me 18. My numbers over on the product side, the top ones, also have to equal 18. So I already know that I have 12. 12 plus what number will also give me 18. The easiest way to figure that out is to subtract these 2 numbers. 18 minus 12 gives me 6. So that means that my mass number that's missing is a 6. All right, now let's take a look at our atomic number. 7 plus 2 gives me 9. Well, some number here plus 6 must give me 9. To figure this out, subtract 6 and 9. 9 minus 6 gives me 3. So that means that I have an atomic number of 3. The final step that I need to take is find the element that is atomic number 3. And here it is, lithium. And so that's how you solve nuclear equations. I hope that this video helped. See you in class. Let me know if you have any questions.